Good evening, everyone. Happy to welcome you all. I am Muhammad Munir Jaman Bapari, CTTC Chair of ASHRAE Bangladesh chapter. Today we got Mr. Shrek. So today's topic we have is on building information modeling for the mechanical discipline. He is one of, we are very honored to host him today. So before proceeding with his lecture, let me address his biography. Now, Mr. Dennis M. Knight is a fellow member of ASHRAE, has more than 46 years of experience in building design, construction, commissioning, and HVAC system. He is the founder and the principal of Whole Building System LLC, a high-performance building consultancy in South Carolina. Dennis holds a bachelor degree in physics and is registered in both mechanical and fire protection engineering. He currently services as vice president. I guess now he serves as a presidential member and a board member of ASHRAE in an ASHRAE fellow. He is an ASHRAE fellow and a member of epidemic task force. He has also authored numerous publications on building information modeling and integrated building design. So let's welcome Mr. Dennis M. Knight. So Dennis, you can share your screen and we are happy to start. I think you have to unmute yours.
All right, Money, is everything looking good on your side?
Yes, it is.
Yes.
All right. All right. Well, good evening, everyone, or good day, depending on where you're at. I want to thank you and thank the Bangladesh chapter for reaching out and organizing this. I know there's more than one chapter represented here tonight. But we're going to talk about building information modeling, and specifically as I get into the later parts of the presentation about how it can apply to the mechanical disciplines. And if you're not already involved in BIM and using BIM as a tool, I hope that this might give you some ideas as your clients and your customers begin to use it. And as we begin to pair it with AI and automate some design processes, I think it's going to be critical that we transition to this technology sooner than later within our profession, within our trades. I'm going to go through a couple of slides here. These are just continuing education slides that I have to put up for the DL program. So what are we going to, we're going to focus on integrated building design where everybody works together, and then how building information modeling applied to the HVAC systems can help with early collaboration, better decision making, and actually get you a seat at the table earlier and keep you there longer if you're wanting to develop clients for a lifetime. I like to share this quote because I believe it's the epitome of the ASHRAE meetings and what we're all about. We are about conversations. I won't read the quote. You can read that for yourselves, but that these conversations we have at ASHRAE meetings and during our meetings every month and with our colleagues, they're critical to our success and or failure, the lack of having these conversations and the lack of maintaining a mindset of continuous learning. So one thing, the improvements in technology since the dawn of the industrial age and really since the printing press has allowed mankind to continually improve their standard of living. I've got the gross domestic product in US dollars per capita over on the left here. And you can just see that since we developed the steam engine and then the World Wide Web and now AI, the opportunities to improve the human condition, raise all boats, and help us all live better, more healthy, and safer lives are just get greater and greater by applying technology to help us do our work and be more productive and do better jobs and build better buildings. So we're going to talk about BIM. We're going to talk about integrated analytics. And this is what I want you to take away from this presentation is that let's don't think about this as a drafting tool, a three-dimensional drafting tool. And you'll see what I mean as I get further into it. But how we can automate some of our design, what some of our future trends are, and where these technologies fit into our codes and standards, and especially some of the ASHRAE standards that are coming out. So what is integrated design? Way back in 2007, I was a chair of TC 7.01, which is integrated building design. And we wrote the first chapter in the ASHRAE Applications Handbook on integrated design. It's chapter 57 in the Applications Handbook. And we defined it as the interaction among all building disciplines from earliest concept development all the way through the whole building life cycle in order to achieve an integration of design efforts and the operation of the total building. And that's key. Normally our contracts stop at the end of design or at least construction when the owner takes occupancy, but these tools and integrated design processes are thought of as a way to stay with the building throughout its life cycle and keep it working as it's always been intended from day one, and keeping us involved for longer periods of time. So what is BIM? You all, I don't know if you use US standards or ISO standards or CEN standards, but the definition's about the same in all of them. A BIM model is a digital representation of both the physical, so that's the three-dimensional drafting part I talked about, and the functional characteristics of a facility. And the functional characteristics are what each object or entity within the building does, what it's made of, what's its emissions nowadays, what embodied carbon, what is its operational carbon. Functional characteristics are data that can be built into the objects within your model so that we can do analysis. So it's a shared knowledge resource that follows the building and helps you make better decisions throughout the life cycle of the building. There are lots of tools. These are just a few. This isn't meant to be proprietary. There are literally hundreds of tools out there that either are a BIM tool or now that are interoperable with your BIM tools to help you do your analysis. And so I won't dwell on this long. I just wanted you to know that the word BIM is an umbrella that covers all of these tools that are working in this multi-dimensional environment. And then integrated building design is a process. That's the end game. We use these tools so that every component is modeled and drawn using these tools. Data is added to it, and the output is a holistic product that can solve many chronic problems within the building industry, whether it's with design, whether it's with construction or constructability, or operability of a building. Now, I've been talking about this since 2000, so I've been talking about it since 2000 for 25 years. I said adoption will not happen overnight, and it hasn't. And we still have a long way to go throughout the world and even here in the US with everybody adopting these technologies. But it requires us to think about a building like we would build a building from the ground up and really think through, if we're going to leverage the power of the technology, think through every decision we make, every piece of equipment, every material we put into a building. So why is integrated design important? I mean, um, we need to study well buildings to accentuate the positive, but normally what we have to do is look back at our coordination issues and things like that to figure out that, hey, we need tools where we're all working inside the same environment to avoid mistakes like you see on the left or the picture of this college dormitory on the right. And that is a real picture of a dorm room in a Florida campus. And it actually happened about 400 or so times before it was caught at final inspection. So it was a big change order to fix the problem that we had electrical panels inside a shower. What is our current process? Even now, our stakeholders kind of stay in their silos, and our workflows are contained in those silos, and rightly they should be. We should work within our area of expertise, but our handoffs are poorly coordinated between each other, and that causes things like change orders, value engineering, or you'll see I call it value elimination here in a few minutes, budget overruns, schedule overruns. And when we make changes, we often don't think about the life cycle cost of a building and not thoroughly vetting those things early enough. So I'd like to go through a little graph that describes this process fairly clearly. So on the left, you have cost, effect, and effort. On the bottom is time, design, construction, and operations and maintenance. So if you were to look at this, our ability to affect the cost of a building diminishes the further down that timeline we go. The more decisions that get made, the less ability we have to change the outcome of that building, what it will cost initially, and how much it will cost that owner throughout its lifetime. And conversely, as we go down time, the more decisions we've made and set in concrete, the cost of making changes goes up exponentially. So we don't get into construction and decide, we've got half our HVAC systems handled and they're chill water, hot water, um, air handlers and VAV units, and they say all of a sudden we're going to go to packaged rooftop air handlers. The cost of that change would be astronomical. So making big changes down the road costs us a lot of money. Our typical design process is we're all waiting for our other friends in those other silos to get done with their work. We want to let them get done. We only want to do our work once. So we wait. Then we finish up our work. The work comes in over budget, and then we have to work to get it under budget and get it back on track. And what happens is we go through that ugly value elimination. It's called value engineering, but it's someone proposes a list of things to cut cost. An owner accepts those things without thinking, maybe without running things by other people. And then we end up with things like this, where something got eliminated that was of value that should not have gotten eliminated. And those things actually happen in real day-to-day construction. So we want to eliminate this value elimination phase or value engineering phase by thinking about things early and create what I call the ideal decision-making process. And BIM allows us to do that because we can build that building virtually in our minds and our computers and do anything we want to it and simulate it before we ever put the first shovel in the ground. And that creates this ideal decision-making process. And that's the real definition of value engineering in my perspective. So let's look at where we're at. We are at this crossroads. There's still a lot of firms using two-dimensional drafting processes and A lot of our building code officials still have to use two-dimensional drawings and plans and spec books to evaluate a process. And those are static. And they, other than the data that you can read in them, that data is not very interactive with anything. So we're in the process of transitioning to what I call a multi-dimensional virtual work environment. Notice I didn't say three-dimensional because I want you to think beyond drafting. Now, some of us are beginning to work, if we're a big firm, we work with these BIM models. There's a central server somewhere in our office, and all our disciplines are together. Each discipline might have a local model that interacts with a central model on a server somewhere. And that's good for bigger firms. But probably 90% of the market in the world is small firms, 5 people or less, working together on projects. And you'll have a primary design professional, often the architect, has a central model, and all the consultants doing their specialty discipline work will work and at some point update that model. And that's still a little cumbersome since you're never working together in the same model and being able to keep up with the changes from all the other disciplines. And then that really requires us to backtrack some and catch our model up on a routine basis. But now there's the capability, and most people that are using BIM now are able to work with a cloud server. Every discipline, whether they're in the same office or whether they're 1,000 miles away in different offices, are able to work in a cloud-based model and share that model in real time and stay up to date with changes that are going on. Now I'm going to shift gears. And I'm going to start talking about the mechanical disciplines here and how we can leverage these tools to get a seat at the table earlier and begin to create more value for ourselves and our clients and our and if we're working with an architect, our clients, the owners of the building. So here's an overview of what we can do with modeling and analysis within a BIM. We can start. There's tools built into our BIM tools to allow us to do very early stage energy modeling, load calculations, and estimations. So if you're working in a design build situation, those early and more accurate estimates that are based on more than rule of thumbs that allow you to run a building in 8,760-hour weather locations that are local to you. You start with just a concept and massing. It could be just like a shoebox with the percent glazing on the sides and the number of floors, and begin to track um, what your EUIs, your energy consumption, what are some of your metrics you're trying. And then as you move along the timeline, as the architect and the owner define and more develop, you get into schematic facades and can rerun those without throwing away what you've already done. And then you get into the detailed documentation and then do room by room calculations and start being able to use the information within the model to then size your equipment and lay out your systems. And then finally, you get into construction phase and as-built design, where these can be converted to digital twins and used to operate and maintain the building. So that's kind of the life cycle of our workflow within a BIM. And you can just start with, like I said, very simple shoebox models. You can run numerous iterations where you've changed window to wall ratio, things like that. You can set targets, say it's ASHRAE 90.1, it's an EUI or Architecture 2030. And just by running these quick models, you can be within 15% of what your final building design might be with just these really fast models and see where you're falling with your EUIs or whatever metrics you're using. And I can see very soon we'll be tracking embodied carbon and operational carbon and zero energy in these metrics as well. And these tools with their digital data capabilities make it much easier to do that kind of work. So what we need to do as mechanical engineers is get comfortable. If you're doing your load calculations by hand through the handbooks, or if you're doing them with a third-party calculation tool, you just need to jump in and start trying some of the tools that are built into your BIM tools. They follow the same processes. They use our ASHRAE standard 183. They use our ASHRAE handbook chapters 18 and all of the information we've used to design systems. And the way I typically design a system, or when I used to do it by hand for sure, I'd always start with the applications handbook, because that would talk about my building, whether it's a museum or a hospital or a school or a fast food restaurant or a laboratory. I'd read about that and I'd see, well, what systems have been employed in there and what seems to work best for that type of building. Then I'd go to my systems and equipment and read about those systems and equipment. And finally, I go to fundamentals to do my calculations. And that's the process that's built into these options on your toolbars in your BIM tool. And I would say that then next, I would go to my colleagues at my ASHRAE meetings, and I'd go to the ASHRAE journal to look at for recent articles on building types and systems like I'm thinking about, especially if I'd never designed the system before, to educate myself on what other people are doing, what my local labor force is capable of installing and working with, and those kind of things. And then start building my models inside the BIM tool. And you use the same settings that we do in third-party tools. You have detailed model information, building type, occupancy, operating schedules, systems. Location, the weather files are the same as they are in your third-party tools. And then you begin to break it down, and whether you're doing heating and cooling loads, duct pressure loss, pipe pressure loss, if you're an electrical engineer, your panel schedules. Schedules and quantities are great design tools. Whether you ever show them on a drawing or not, you can create schedules that you can use to help you get comfortable that your design looks the way it is, and you can help contractors and owners understand more about what's in your building by creating schedules that may not show up on a drawing, like number of pipe fittings, type of pipe, number of air handlers, pounds of ducts, square feet of insulation, number of valves. You can extract all of that data from that model without ever having to go create a spreadsheet outside the model and count all of that yourself as you're designing. So the model inside, the analytical model for cooling loads, does just what we do. It converts the building into one-dimensional heat transfer surfaces that has all your R values, U values, material mass, those kind of things built into the little boxes that make up the spaces that we're going to analyze. Then it allows you to break those down and look. You can get warnings that something doesn't look right here. This room doesn't have any attributes assigned to it yet. And then even drill down then into a single space and be able to analyze what's going on. Are there exterior walls, interior walls, and what's the roof like? And just check your model that way. Very visual. And that's really required if you're using the more modern heat balance method of the ASHRAE handbooks, which is just a little more accurate way of calculating your loads. And then we get our building summary, same kind of reports we get. You get peak cooling loads, block cooling loads, you get checksums to look at square foot per ton, kW per ton, square meters per kW per square meter, and things you're used to using to gauge whether you feel like this model is something that you can hang your hat on and begin doing design on. So I'm going to walk you through. I didn't put the building on here intentionally, just how you might start playing around. You don't even need a building to start getting in to these models. Just create a model and start playing around with doing some sizing and some calculations. So say you've got a space, you've got 4 grills that's 250 CFM a piece. So you got 1,000 CFM. You draw a duct. You don't put a size on it. You never go look at a ductulator, anything like that. You cap the duct, run some flexible duct out to it. Um, And then you begin doing your analysis using, say, that duct pressure loss calculation. So you go into the duct sizing methods within the tool. You can pick equal friction. You can pick static regain. You can add safety factors or change the pressure loss per 100 feet. The system uses the ASHRAE duct fitting calculators to calculate the fitting losses very accurately. Your branch sizing you can change to restrict the height, width, if you've got a structural limitation, and those kind of things. If you're doing, say, dust exhaust or wood chipped exhaust, you can change it to a velocity setting if you, say, need to keep the velocity above 2,000 feet per minute or something like that. And then you let it run. And so here it's run the calculation on this little piece of ductwork. The red line shows your critical run, the longest run. And if you were to have an air handler right where I've got that red box here, this tells you that you'd need a stove to get 1,000 CFM through that duct and get 250 CFM to your last grill. You'd need 0.13 inches of external supply static pressure on that system at that point to do it. Very quickly, you can do these types. Then you tell it to automatically label everything. So you never have to go in and put labels on now. You can see your system in 3 dimensions as you're laying it out. So now let's add some equipment to that and see how much further we can go with this analysis. So here's some equipment. There's your grills. This time they're a little different. I've run the ductwork, done the calculations for the dedicated outdoor air system. I've got my outside air intake, my supply air, my ventilation air system laid out. I can go straight then from what I've picked as a dedicated outdoor air system, assign properties to that outdoor air system here. And those can be, this goes on and on. I certainly would add the BTUs or the KW, the sensible, the latent, the power requirements, the sizes and things like that. And then take that straight to a schedule that doesn't have to be exported and created in Excel or something like that and then cut and paste it into a drawing. This is automatic. And then once you've linked all of this together within your model, if I change this DOAS, it changes the properties and it changes the schedule. Conversely, if I change the schedule and the scheduled amounts, it does the reverse. It changes the properties and it changes the piece of equipment inside the model. So it's a circular process, forward or backward. Once you've created this and linked all this data together, you change it once and it shows up in every place. And you don't have to remember that there's 10 places that I've got to go in these drawings to change that information and end up with errors in a bunch of drawings that you end up with the same unit shown in 2 different sizes somewhere. And then contractor, of course, ultimately picks the lowest cost option, and that might not be the one you want. And that ends up with a change order for you. You can continuously coordinate with your colleagues, the other stakeholders in this integrated design process. And and keep this going, iterating design and keeping up with the way everybody's changing, structural, architectural, civil. And then something I've begun doing is when I get a call for an existing system that I want to analyze that there's issues with, I'll often go and I'll just go out to the field, I'll measure it, I'll get nameplate data, I'll come back without a building, I'll sketch out with all the dimensions, and I'll begin doing my analysis to help me do a better job. And that gets me used to working in one tool and doing analytics without having to jump around. And I'll learn more about the tool by even analyzing these systems without buildings being attached to them. So what are some of the things we're doing today? We're focusing on what we can do with the information. And with AI, this is going to be so critical because it's going to be able to help us analyze all the data within these BIMs at a much faster rate. It's going to allow us to ask questions we've never asked before, which will help us optimize our designs much better. We're using these tools, like I said, the little early phase energy modeling tools to get a seat at the table sooner, maybe an increased fee for doing that. We're trying to work around life cycle cost and cost benefits, so eliminate that value elimination phase and move into that ideal decision making process. We're learning the tools. We're trying to learn all the processes and capabilities of the tools. So we do training and go to different training exercises and watch videos and sign up for the developers training as often as we can. And then we're expanding our services offerings beyond construction to maybe help develop a digital twin. Or if you've got a spec office building where tenants come and go and the building gets renovated fairly frequently for new tenants and new floor plans, we're offering the service to help the owner maintain that BIM throughout the life cycle. Because once you've got it in an as-built condition, rather than running out there with your ladders and your tape measures and your paper drawings and marking up what's been changed since the last time you worked on the project, if the BIM is kept up to date, you always can get started right away working on the new project you've been given with an existing building. This is crucial in laboratories and hospitals that BIM models be kept as built to help with operations and then help with changes, because these buildings get reconfigured all the time for researchers and surgeons and things like that. We're looking closely at what can we automate. So can we automate that duct design, that equipment layout, those schedule creations? And then determining what software we no longer need. Well, maybe if we can do it inside the BIM, we don't need something for pipe pressure loss calculations, duct pressure loss calculations, load design calculations, pipe stress, those things. There are interoperable tools that are made to work with the BIM and work with our systems for that. And then working at what level of detail is required. And ASHRAE has a really good standard now, ASHRAE standard 224, that I had the opportunity to be one of the authors on, that is really written for the owners on what level of detail to ask for depending on what you're going to use this BIM for. Are you going to build the building and never look at that model again? If that's so, you don't need that much detail. Are you going to use this model throughout the life cycle and even help operate and maintain the building? There's a different level of detail required to go into that model for that owner to be able to do that. We're helping the clients determine what to ask for in those contracts, and Standard 224 does that. And then we're looking 5 years, 20 years out. Can we help them maintain that model, keep a client for life, keep our revenues up, and stay at the table longer? Integrated project delivery is a new contract method that's particular to the AIA, or the American Institute of Architects, where every entity within the the project as a stakeholder until they turn it over to the building. So you kind of own a piece of you own your piece of the building and responsible for it getting designed and built correctly before you give it to the owner. Integrated specification writing. There are a lot of specification tools now that you bring in a piece of equipment, a chiller or an air handler that goes ahead and drafts the specification if you've got your office standards set up correctly. Automated cost estimating, contractors are already using this pretty heavily now, especially the bigger government contractors that do work for the governments on these bigger projects. Advanced clash detection has been one of the real key features that's been around since day one, really, and getting better all the time, that catches these clashes as you go. But I've been told by some contractors that that one feature alone has saved them about 15% on the cost of construction by being able to do clash detection early and not have to tear out a bunch of stuff when you run into some other discipline's work. BIM to fabrication, we have a provider, a contractor, a fabricator up in North Carolina that fabricates pre-engineered central chill water plants for data centers. And they are actually booked up. They've got over 1 million square feet of fabrication, and they're booked up through 2030 with contracts to build data center central energy plants that are fabricated in a factory and then shipped all over the world. A very powerful tool. And they integrate everything from drawing to cost estimating to stress calculations to purchase management from just the data that's kept inside their BIM model. And then, of course, BIM to simulation, the things we've been talking about: energy modeling, duct calculations, load calculations, daylighting, CFDs if you're doing laboratories and operating rooms and things where you really need to look closely at what your airflows are within a space from a health and safety standpoint and from a process standpoint. A lot of cloud-based tools now. Cloud-based BIM servers, that used to be a thing that was a wish list, but there's plenty of them. We've got increased operability. There are more integrated applications. And we're trying to increase a focus on the owner benefits beyond design. So operations and maintenance, portfolio and asset management, and energy management. And now you can add to that carbon emissions management as well. Virtual design and construction. So doing everything inside the model before it's done. It's a fast growing segment of the market. And virtual reality, being able to walk through a model with a VR headset on and see what the building might look like and what your systems look like and what they might run into. Augmented reality, so you're taking it out to the field with tablets, headsets, being able to lay out your plumbing, lay out your ductwork, lay out your hangers and mark them accurately with an augmented reality tool built into the BIM. Digital twins, very popular to help maintain the asset, both the operational carbon emissions, the embodied carbon emissions, the energy consumption, the maintenance schedules can be laid on top of your building control system, your owner's financial and asset management systems to help leverage the data in a BIM. Off-site construction, like I mentioned on the data centers, but there are firms in Florida I know that just focus on fabricating pipe tunnels for big central heating and cooling plants for cities. These tunnels will be built, they'll fit together. They're made in sections to go on tractor trailers. You go out to the site, dig your trenches, pour your foundations, and set the sections in place and connect them up. And they've been built, tested, and fabricated in a clean factory environment. So you don't need a lot. You need less laydown space on your site. The site's safer because of that, things like that. A a lot of prefabrication, modular construction. And right here in my own backyard, about 50 miles away, we had a small rural town whose hospital was destroyed by a hurricane, and the State Department of Health wouldn't let them reopen it. And the answer was we had a modular hospital built in a factory using BIM tools, brought to the site, and then assembled in parts and pieces and modules that went together with very close tolerances. You can see the list here. You go down to, there are beginning to be tools that'll check for codes, just like you check for spelling in a Word document, and then maybe issue an automated permit, which would speed up time and help an owner. Time is money to an owner. So the longer you're in construction, the less money they're making, or the less products they're producing, depending on the type of building they're building. And you can see the list, and the list goes on and on. We've got AI and generative design now. One little book we wrote back in 2010 is an introduction to BIM. It's available for free download. It's got a lot of the information in this presentation in it. It's got a lot of tools. Believe it or not, it's not terribly out of date, even though it was written 15 years ago. Most of the tools are still around and gotten better. But it's a great primer. If you've not tried anything yet, just go to the website, type in the introduction to BIM, download it, and read it before you start deciding what kind of tool to buy. I mentioned Standard 224. Its primary audience is an owner. Its adoption by owners will help them write their contracts to ask you for the correct level of development in these models. It was based on the National Institute of BIM Standards, National Institute of Building Sciences, National BIM Guide for Owners. ASHRAE and NIBS partnered to write a joint standard, and we've got it ANSI approved. And it goes through planning, design, construction, and operation, and what would be required in a BIM depending on where you're going to stop in that hierarchy. And I'll just skip through this. So what are some of our current barriers as we get to the end of the hour? Because I have a fairly hard stop at the end of the hour for another meeting. But I said, again, adoption of a digital practice mindset. You've got to think, how can I automate this? How can I stay in this one environment? And what are the things I can do and document well enough to know I've done my diligence and done a good job for my owner and my client. There's still a bit of lack of interoperability, limited parametric design. So the best parametric design example I can give you is making a change in a schedule or on the drawing tool or in the properties and it propagating to everything. That's parametric. We're not yet at the point where if the architect or the structural engineer, the mechanical engineer, civil engineer makes a change, that all our other systems try to suggest a new design or an adaptation of our design to fit that change and let us know whether to accept it or reject it. That's coming, though. With generative design, we will soon be able to, when an architect makes a change to the building that we've already laid systems out, our systems will then generate a new design change suggesting to us what might work. And then we have the opportunity to accept it, reject it, or make changes to that suggested change. That will be the day that we've got true parametric design features. Handling of information. The handling of information is critical, and as long as it's in one model, you're good. I would say that a caveat there is if you're bringing in equipment and entities from manufacturers' websites, be sure to clean those properties up and only keep the information you're using on your project. If you're bringing in an air handler just to get its size and it's got a lot of information associated with it, and someone down the road goes and tries to use that data for something else, they could be using the wrong data. So be careful when you bring manufacturer's equipment into a job, that you reduce its level of detail, its level of information to only the information you need for that project. That can help you eliminate errors, omissions, even lawsuits and litigation down the road. But it allows us to do consistent application. And right now, everybody has their own office standards. Everybody does things a little differently. So Standard 224 and other standards like that, ISO 19650, we're trying to change that and get everybody to do things, not be the same type of designer, but do the same things following the similar process, a similar quality control process. ASHRAE is developing smart documents that can be read, our handbooks, our standards, that can be read by digital tools to help us create these tools that automatically check terminology and load calculation methodology and weather data. This is just a small list of the TCs that are working on these things. So some resources, and I don't think I put the ISO one, but ASHRAE Standard 241, the Introduction to BIM, the BIM Council, if you're able to get to it, the National Institute of Building Sciences, Whole Building Design Guide, and then ISO. So ISO TC 59 and Subcommittee 13 primarily deals with our work. They have a series of standards called ISO 19650, and I think they're up to 5 parts now. That may be what your local jurisdiction requires you to use. So you would want to focus on that. And with that, I think I got about 10 minutes or so for questions and answers. So Money, I'll open the floor for conversation if you don't mind, and we'll
Thank
we'll
you
talk
very
about this.
much this night. It was a wonderful presentation. And now we are open up for questions and answer. If you have any question, please raise your hand, and I'm going to call you one by one. And if you are feeling shy to ask a question, you can write your question in the chat box. I'm going to read it out for you. Right. So our first question will be coming from Mr. Badru. So please unmute yourself and place your question. Yes.
Okay. Thank you so much for this beautiful presentation and educative. Please, I want you to advise us on how we can use this BIM for the indoor air quality program, which is now what we are trying to do in terms of indoor environmental quality. And also,
go ahead.
So how much does this cost to process this software or BIM? Thank you so much, sir.
Well, I mean, if you're already using a tool, most of the major tools have all of this built in. So if you're able to do load calculations, the advantage to BIM, many of our ventilation standards are either focused on square foot, volume of the space, air changes per hour, or ventilation per person. And within a BIM, if you've set up your load calculations, you've got your occupancy density, and things like that. You can pull from ASHRAE standard 62 tables. You can standard 170 for hospitals. Set that up and run those calculations right inside the BIM, and they'd be more accurate because you've got accurate building spaces, volumes, your occupancy loads. And that really wouldn't cost you any more money if you're already using a BIM tool. Now, if you're not using a BIM tool, you have to just go evaluate the cost of maybe changing from a CAD tool to a BIM tool, but you're able to do those calculations within the BIM. You could even create a schedule. If your tool weren't able to do it, the schedules I was showing you back on that page, let me go all the way back. I'll get back to it real quick. Oh, too many little, right here. So you could create a schedule. So these schedules then can be created. You can add columns and rows, and just like a spreadsheet, do calculations. So if you were able to extract, say, from an architectural model, room name and number, and location, it would extract, you could extract the square footage, the volume. You could put your rates, whether they're CFM per square foot, whether it's air changes per hour, where it's CFM per person. So you could add a column number of people. You could pull that from your load calculation software, do the calculation, and have a schedule there that would show you what you need for every space in the building. And that all could be automated in this process. And then say you needed to change something, you just work in the schedule to change it, and it propagates it all the way back through your system. You may have to do a little bit of work if you were to go from, say, 500 CFM of outside air in a system to 2,000. You may have to go back and tell it to rerun duct sizing calculations. And but what you would do there is create you a schedule with your diffusers, their CFMs, change the diffuser CFMs, and then go back and rerun and let it automatically size it. You wouldn't have to go in and erase things and do things like that. So you could very quickly automate that whole process, and you really wouldn't have to buy another piece of software to do it.
What are the costs, sir? What does it cost to have the tool?
Oh, well, that depends. I don't know. It would depend on, and I'm not able to talk about specific tools, but there's Revit, there's ArchiCAD, there's Bentley, and all of those, you just have to find a local rep and get a cost, and then decide whether you're going to keep your CAD tool and a BIM tool, or whether you're going to learn everything you can. I draw everything in BIM now, whether I'm using the BIM data or not, and then just set up my sheets, because I've got my schedules, my sequences of operation, I've got all my notes and everything in a model template, and I never have to write those again anymore. They stay in my template, and then I just drag them onto the sheets that I want. Even if the owner didn't require BIM, I'm working in the BIM tool to do my work and produce my drawings. That of what it costs is kind of a hard question, because I really don't know what the market for BIM tools in your area are, or who the BIM software developers that most of you use are. I mean, the big three are ArchiCAD, Revit, and Bentley, but I know there's others out there. But it can be, just I mean, it could be a big expense if you're a big office. If you're small, there's subscription services, so you can pay for these things on a monthly basis and have cloud access to your models and things like that. But yeah, I don't think I can answer the question on what it costs you.
Thank you. Before proceeding to our next
Thank you so much, sir.
question, thank you, Mr. Badru. Before proceeding to our next question, I have shared a link with you to review the session of Mr. Dennis Knight. You just have to follow the link and put the name Knight only, KNIGHT, and you can give your review on the session at that particular link. I'm sharing the link again. And the next question will be from Mr. Ershad Jaman, President-elect from ASHRAE Bangladesh chapter.
Okay.
Hi, sir. Uh, mm, Thanks for your nice presentation. You much clear about us, and it is really important, especially for our engineers, and also got interested our new engineers, especially YE engineers. And actually, as of my question, by the beam, we can do also some load calculation in partly, but while we do the like HVAC calculation by the other software, those are more accurate. So, is it possible to integrate with the beam? That is my one question.
Yes, I think now through if you've got the same naming conventions in both your BIM model and your third-party software that you're more comfortable with, and I'll name a few. Again, I'm not promoting one or the other. If you are using Carrier Hat or Trace
Yes.
3D or IESVE, they all have capabilities to work with a BIM. I will tell you that, in fact, I'm working on one right now where I've been asked to use one of those third parties. It's a little bit of a cumbersome process. If the architect has gotten really ahead of you and there's a lot of information in that architectural model, bringing in just the geometry gets a little difficult because all you really need in your third-party software is geometry. But you do that by exporting and importing what's called GBXML files. That's a standard load and energy calculation transfer. And I will typically ask it to export geometry only because my tool will usually allow me to then set up my wall, roof, glass, floor type construction and calculate their mass and their R values and U values and shading coefficients a little better. So I'm used to that workflow too. I like working with some of the third-party tools, but the reason that almost every one of them have gone to having to use a three-dimensional model is because ASHRAE's latest handbooks really focus on the heat balance method, which really requires you to have a three-dimensional idea of everything in space. Because unlike the Radiant time series, the RTS in the older handbooks, where you just had a mass and an R value, and most of your loads were calculated as instantaneous, the heat balance method is dynamic. And so it's looking at solar radiation and is it hitting furniture? Is it hitting a floor? Is it hitting a wall? And it's dynamically changing all of that. So you have your instantaneous loads that are in the space, and then you have your ever changing loads that are either solar generated or weather dependent or ventilation dependent that have to be updated hourly or even minute by minute. It's a more accurate way of calculating things, but it almost requires a three-dimensional model or a three-dimensional representation of a space to do that calculation method correctly.
Sure. Since it is highly effective solution regarding the beam, especially you say in our from like in Bangladesh, we are not much used to total complete beam.
Right.
Complete beam. So, is there any presentation like show the sample project who is already completed and found this kind of data, then it will be more visible to us. And I also requested to our CTTC chair, can you arrange, or if you have, sir, any presentation, maybe we
Okay.
can.
All right. So again, I'm going to step away. I'm not a distinguished lecturer at this moment. Okay. I'm just an engineer talking to an engineer. All right. So one of the best presentations I've seen, and if you'll send me a note, I'll find the link. I'll find it and send it to you. But it's by a young man named Ian Malloy. He works for Autodesk. The interesting thing is he did this simulation, he did this workflow presentation using metric units. Okay, he doesn't have an SI, an IP unit version of the presentation, but it actually walks you through how to set up just a model to do your load and energy calculations. Creates a lot of schedules to help you get comfortable with, well, is this engine doing what I need it to do? But that is the best presentation to date I've seen on it. Okay, so now I'll put my DL hat back on, and we're not talking proprietary things, but from a third party load calculation standpoint, the Carrier HAP, the Trace 3D, and the ISVE, they all have good training videos on how to go back and forth between BIM models, pretty good. So you go to any one of those websites, go to their on-demand training, and take a look at some of their demonstration projects. And they'll do it on small, even one space. And so one of them uses the ASHRAE headquarters and actually uses just the open office space of the headquarters to do a load calculation. So it's a nice presentation, but they're out there. And again, if you want to, again, at the end of the presentation, here is my email. I'll get back to that questions page very quickly. And if anybody on the presentation.
I can share your details with our participants.
Okay, but yeah. So if you'll send me a note, I will be happy to put you in touch with a subject matter expert that's doing work in that area, if possible. I do work with some of the national laboratories. I don't know that they'd be able to share some of the things they're doing, but they're working very, very hard to use AI and generative design to help build some of that that power of data analytics and start creating not just large language models, but actually physics-based models, models that can manipulate data and do calculations and not just talk back and forth to you in text-based formats.
Thank you, sir, for your useful brief. Thank you.
Yes, sir.
We are going to allow one or two more
Ooh,
questions.
okay. I actually am gonna I'm gonna have to run. I've actually got another meeting that's already started.
Oh, okay.
I apologize, but
I'm going
yeah,
to
it just seems I got booked up today, so
no
I need to
issues.
hop on that other meeting. I'm sorry.
Okay,
But send me the questions. I'll do my best to answer them.
Yeah.
Okay.
So I'm going to compile all the questions and send it to Mr. Dennis Knight. Please do
Yeah.
WhatsApp me all your questions that you have. Finally,
And if you want to put them in an email to yourself, I mean, from you, I'll write the answers under the question, and then you can just send them to everybody.
Yeah,
okay.
that I can do for our
Okay.
participants. Finally, a vote of thanks from our President-elect, Mr. ASHRAE.
Yes, thanks for the questions. They were great questions. That's usually the best part of the session. Yeah. All right. Well,
first of all, thank you, sir, for your useful presentation. So we can want to thank you, and thank you everyone for joining. We see more than 100 participants joined. Thank you. Thanks to us.
we are going to
So thank you
host
all, and I apologize for having to
No, no,
leave.
sure, sir. Thank you. You can.
Thank you.
Thank you,
Okay.
Dr. Dennis Knight. We are going to host Dr. Dennis Knight more often. I guess in this calendar year, we are going to have 3 more sessions on Dr. Dennis Knight. He is going to be available with us. Coming up, our next session is going to be on ASHRAE in the house, past, present, future initiative in residential building performance from Dr. Teresa Weston. It is going to be on 15th of September, coming Monday. So till then, have a good time. Good night.
Good job, Mr. Gapari.
So,
Very well done, Mr. Murujaman. Mr.
thank you,
Murujaman,
sir.
you did a very lot of good.
অনেক ইন্টারেস্টিং টপিক আসবে
Brother Hashmut Bhai, now you have time to switch your this event, this platform to your MP chair training session. It's already started. Please.